Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting another sum of Macaulay's double integration method. In that we are seeing the fixed end part. Now we are in previous lectures we are seeing with the overhanging part and reactions of roller and hinge part, and here we are taking a fixed part. Fixed, one end is fixed and other is free. We have to find over here slope and deflection at free end. Let's see details. Now this is a theory question given to you in exam. Sometimes a cantilever beam of length L is subjected to a UDL of W per unit length. This is nothing but W per unit run. At the free end, use double integration method. This is your free end B and this is your A. Now a cantilever beam of length L. Length will be L. This is nothing but span. Okay, this is your span. Now what we are doing over here, see, determine the slope and deflection at the free end. We have to find the slope and deflection at free end means at B. Okay, now so what Macaulay says for us, take a section extreme corners, or if UDL is there, take the section from the UDL. But in fixed beam type problem, don't need to find the reaction once again. No need to find the reaction because we are taking always in left side. So take a section over here like this and take a distance x from B is the origin, and this is your origin over here. This is nothing but x. This is x. Ignore this part because if you take section over here and take this part, we have to find this reaction VA, VB and that moment. So always neglect the fixed part in cantilever beam problems. Okay, in fixed part always neglect. So no need to calculate the reaction. Directly solve by using double integration method. This is of theory part. After that we will explain one sum also. Okay. Now see. Now how it comes, see, we have to take a bending moment over here and take B as origin. So using double integration method, now see, we have forgot one things. We have not drawn the box over B, as B is origin over here. So our first box will come over like this. X is equal to, what's value we get? X is equal to 0 over here. Now we have to write over here one box. Here we have to know X is equal to nothing but L. Okay, now using double integration method, what we have to do, bending moment at x is equal to EI d square y upon dx square is equal to, okay. Now see, we are taking section over here. What's the value come in here? See, this will go in this direction, means hugging. So minus w into x by 2, minus w into x by 2. Okay, now that's it. No another load is over here in this side at origin B. So rearrange it, minus w x square by 2. Okay. Now after that, integrating, after this will get the equation number 1 for us. Now we have to integrate. Now what we have to do, integrate this one. So integrating what's the value will come over here? EI dy by dx is equal to, now see, minus wx raised to 3 upon 6 plus c1. This is nothing but equation number 1. Now keep that, remember in one thing, in cantilever types of problem, always apply the end condition one by one. If you are integrating one equation, apply the one boundary condition. After that, because in cantilever we have only one boundary condition, which is nothing but this one. we have only this boundary condition, x is equal to L, but y is equal to 0 and dy by dx also equal to 0. So we have to take in cantilever, please listen carefully. In cantilever, always do the separate parts. Let's see how it comes. See, after one, what we are doing in previous sum in simply supported types of problems, we are integrating again, then apply the end conditions. In cantilever, now we have to apply the end conditions. See, like this. Now first boundary condition. Now what is our first boundary condition over here? First boundary condition will over here at x is equal to L and dy by dx is equal to 0. Okay, now see here, x is equal to L but theta will be 0, means dy by dx also is get 0 over here. That's why from equation 1 we got the value will be, write down over here, 0 is equal to minus wl raised to 3 upon 6 plus c1 is nothing but c1 is equal to wl raised to 3 upon 6 over here. So our c1 value will be wl raised to 3 upon 6. Put in equation number 1. Now how will you get the value over here? See, we get the answer over here like this: ei dy by dx is equal to minus wx cube upon 6 plus wl raised to 3 upon 6 is nothing but your a. Your a is nothing but journal slope equation. In cantilever part, you have to calculate the separate. First we have to integrate one time and then apply the first boundary conditions. After that, integrating the again, then apply the second boundary condition. Now after that, see, integrating again. Now integrating again. Now what is your integrating over here? See, ei, what's come here? Ei y is equal to minus wx raised to 4 upon 24 plus wl raised to 3 upon 6 x, means c1x. This is nothing but c1x. We got the value of c1, that's why I'm putting over here. This is nothing but c1x plus c2. This is nothing but equation number 2 over here. Now after that second boundary condition. Now apply the second boundary conditions. Now second boundary conditions. Now what is second boundary conditions? At x is equal to L and y is equal to 0. X is equal to L. Now see, x is equal to L and y is equal to 0 over here. In cantilever type, this is only one end condition is there. We are applying in both of them. This is x is equal to n, y is also 0 because deflection at A will be also 0 over here. So from equation 2, now from equation 2 we get the value over this like this: 0 is equal to minus wl raised to 4 upon 24 plus wl raised to 3 upon 6 into L plus C2. Okay, L into C2. This is nothing but your L. C2. Now you get the value of C2 over here will be wl raised to 4 upon 24 minus wl raised to 4 upon 6. So wl raised to 4 minus 4 wl raised to 4 upon 24 minus 3 wl raised to 4 upon 24. You get the value of C2 will be minus WL raised to 4 upon 8. See, WL raised to 4 upon 8. Okay. Now put in equation number 2. So we get the value will be over here. EIY is equal to minus WL raised to 4 upon 24 plus WL raised to 3 upon 6 into X minus WL raised to 4 upon 8. This is nothing but B, or B is nothing but journal deflection equation. Now in question you have asked, find slope at B will be dy by dx into B is equal to 0 plus WL raised to 3 upon 6 upon EI. Okay. Now put the equation in general slope equation. Now putting x is equal to 0 in equation A, we have to put we are putting over here x is equal to 0 because see, we have to find slope and deflection at B, so x value will be 0 over here. Now we got the value of QB will be WL raised to 3 upon 6 EI. After that, put x is equal to 0 to find YB is equal to 0 plus 0 minus WL raised to 4 upon 8 upon EI. Putting x is equal to 0 in equation B, which is nothing journal deflection equation. So we got the value of YB will be over here minus WL raised to 4 upon 8 EI. Okay, therefore YB will be WL raised to 4 upon 8 EI in downward direction. This is your final answer. Please remember one thing in cantilever, or say ignore the cantilever part and take this origin as right this side or free side. After that, take integrating one time and find C1, then integrating another time, then find C2. After that write the equation 1 and 2 and general slope equation, general deflection equation. After that you can find anywhere slope and deflection whatever asked in the exam. I hope you understand my video. Share with your friends and don't forget to subscribe the Ekeeda channel. Thank you.